In this video, we are going to discuss about the significant figures, rounding off the uncertain digits, significant figure in multiplication and division, and significant figures in addition and subtraction. Let's get started. The significant figures express accuracy with which the physical quantity may be expressed. We represent all the physical quantities or their measurement with digits. For example, we measure the weight of a person and it comes out to be 49.3 kg. Then this last digit is known as the uncertain digit. These two digits 4 and 9 both are reliable and certain. What are the significant figures? The reliable digits plus the first uncertain digit are known as the significant digit or significant figures. Like this, in above example, there are how many significant figures? We have 3 significant figures: 4, 9, 3. 3 is last uncertain digit and 4 and 9 are reliable digit. Let me take one more example. For example, 387.9 centimeter. So in this case, we have 4 significant figures. So there are some rules to find out the significant figures. So let's discuss them one by one. So first rule here is all non-zero digits are significant. For example, if we have a measurement value like 152, so we don't have any zero here, so all non-zero digits are significant. Means in this all digits 1, 5 and 2, all these are significant. So how many significant figures are there in this number? We have 3 significant figures. For example, 4, 5, 6, 9, 3. So how many significant digits we have here? We have 1, 2, 3, 4, 5. So we have 5 significant figures. So all non-zero digits are significant. This is the first rule. Second rule is all zeros occurring between two non-zero digits are significant. So all zero occurring between two non-zero digits are significant. For example, 107.01. So here all zeros which are occurring between non-zero digits. So these zeros are between non-zero numbers. So all these are significant. So how many significant figures we have here? 5. For example, 2005. So how many significant figures we have here? So all zero occurring between two non-zero digits are significant. So these 2 and 5 both are non-zero numbers. So all zero in between 2 and 5 are significant. So we have 4 significant figures here. Third rule here, we have all zeros to the right of a decimal point and to the left of non-zero digit are never significant. It means that if we have a number like 0.0032, so here all zeros to the right of a decimal point, all zero to the right of the decimal point and to the left of the decimal point of a non-zero digit, which is 3 here, are never significant. Means this 0 and these 2 zeros are not significant. So how many significant figures here? We have only 2 significant figures. Similarly, if I take the example of 0.00234, so here also this 0 and these 2 zeros are not significant. So how many significant figures we have here? 4. We have 4 significant figures here. So this was the rule number 3. This rule I have 2 parts, A and B. So all zeros to the right of a decimal point are significant. If we have a number like 30.00, then the all zeros are also significant after the all zeros after the decimal are also significant. It means these 2 zeros are. So how many significant figures? Here we have 4 significant figures. B part is all zero to the right of the last non-zero digit after the decimal point are significant. So what they say, it means that if we have a number like 0.0023000, all zeros to the right of the last non-zero digit. Which one is the last non-zero digit here? 3 after the decimal point are significant. It means that these three zeros are also significant. So total number of the significant figures in this number we have 5, 2, 3 and 3 zeros. So 5. Next we have all zeros to the right of the last non-zero digit and are not significant. Means we have a number like 20. So what they are saying this zero is not significant. So here we have only 3 significant figures. If I take number like 3, 0, 1, 2, 0, 0. So all these zeros are not significant. So we have only 4 significant figures here. 5b is all zeros to the right of the last non-zero digit are significant if they come from a measurement. If this 2020 is not just a number, we have some units also with it. For example, if they are saying that the distance between two cities is equal to 2020 meter, so in this case this zero is also significant. So we have here 4 significant figures because we can measure the distance in different system of units. So in all different system of units, the significant figure should be same. So that is why it has 4 significant figures. So we can write this as, so we can write the distance as meter, centimeter and kilometer also, but the significant figures should remain same, which is equal to 4. So to remove this type of ambiguities, we scientific notation means in the power of 10. So we can express this as 2.020 into 10 raised to power 3 meters, and this as 2.020 into 10 raised to power 3 centimeter or 2.020 kilometer. So in all these three we have same significant figures, which is equal to 4. Take one example. For example, we have a number like this, 2.520 into 10 raised to power 7 meter. So how many significant figures here we have? We have 4 significant figures here according to 5b rule. So last one we have, for exact numbers and irrationally defined number like Euler numbers e and pi have infinite significant figures, so we have exact value for them. So for example, if I expression like 1 meter is equal to 100 centimeter, so here also we have infinite significant figures for this. Similarly for pi we have a certain value like 3.14, but this is irrationally defined number. So for that also we have infinite significant figures. The second topic which I am going to discuss here is rounding of uncertain digits. The number is rounded off to the desired number of the significant figures by dropping one or more digit to the right, which are uncertain digits. So by dropping the uncertain digit, we can round off a given number. For example, if we have a number like 2.356 and it is given that we have to round off this number to 2 significant figures, then what we have to do? First we need to find the significant figures of this number. So here the significant figures are 1, 2, 3, 4. 4 are the significant figure for this number, but we have to round off this number to 2 significant figures. So that we have to do till this. We have to take these 2 numbers. So we have to drop 5 and 6 from this number. So there are some rules for doing the rounding of a given number. So these rules are, so rule number 1 here is, if the digit to be dropped is less than 5, then the preceding digit remains unchanged. Let me explain this with an example. So for example, suppose we have to round off this number 2.325 or two significant figures. So here first find out the number of significant figures. The number of significant figures for this number is equal to 4. Now we have to round off this number to two significant figures. So for that means we have to write only the 2.3. So for that we need to see the next number. This next number is 2. If this 2 and this 2 is less than 5, this number 2 is less than 5, so it means that if the number which we want to drop, so we have to drop these two numbers 2 and 4, and this 2 number is less than 5, then the preceding digit remains unchanged, means the preceding digit to 2 is 3, so it won't change. And write this number as 2.3. So now this number has how many significant figures? Two significant figures. Let me take one more example. So here also, so how many significant figures for this number? 4. So we have to round off this number to 3 significant figure. So for that we have to drop this 1, correct? And this 1 is less than 5, so it means the preceding digit, which is 2, it will be unchanged. So we can write this number as 2.32. so this number has 3 significant figures. So let me take one more example. This number 0.08240, we have to round off to 3 significant figures. The first find out the significant figures for this number. The total significant figures for this number is equal to 4. 8240. So 4. So we have to round off this 3 significant figures, means we have to till this. So this is 0, which is less than 5. So it means after rounding off this digit to 3 significant figure, we will get the number 0.0824. Now next example is we have to round off this number to 3 significant figures. So how many significant figures for this number? The significant figures are equal to 3, 4, 5, 2, 1, 6. So we have to round off this till 3 significant figures, means we have to write only 3 digits, 3, 4, 5, and we have to drop this 2 here. So this 2 is less than 5, so it means we can write this number as 345. Now this number has significant figures equals to 3. So is this the correct way of writing this big number? And we are getting very small number, so this is not the correct way. So we have to put 3 zeros here, so that this number 345 become near to this given number. So now how many significant figures here we have? 3 significant figures remain. So best way of writing these type of number is like 3.45 into 10 raised to power 5. So now also how many significant figures here we have? 3. Now let's see the next rule. If the digit to be dropped is more than 5, then preceding digit is increased by 1. So in this case, we have to increase the preceding digit by 1 if the dropped digit is more than 5. So it means 2.347. So this number has 4 significant figures. Suppose that we have to round off this figure to 3 significant figures. Then the 3 significant figures means we have to round off this number till 2.34. Now we have to see this dropped digit. So this is 7, and this 7 is greater than 5. So it means the preceding digit. So here the preceding digit is 4. So this digit we have to increase by 1. So we have to add 1 to 4. So we'll get this number as 2.34. After 4, 5 will come. So now this number has 3 significant figures. Let me take one more example here. 246.76. Round off to 3 significant figures. So first we have initial significant figures are 5. So we have to round off to 3 significant figures. So means till this we have to round off this number. So the drop digit is 7, which is greater than 5. So it means now we have to increase the preceding number, which is 6, by 1. So my number will become 247. So now the significant figures are 3. So let me take this big number now, 8.9. So now also we have to round off this number till 3 significant figures. So it means we have to round off till 246. So dropped out number here also is 7, which is greater than 5. It means we have to increase this 6. So we can write this number as 247. Is this the correct way of writing the number? Because here we have bigger number, now we are getting the smaller number now. So for that, to balance that, what we have to do, we'll put 2 zeros here. So this is the answer. Or we can write this number in scientific notation, which is 2.47 into 10 raised to power 2. Next, third rule we have, if the digit to be dropped is 5 followed by non-zero digit, then the preceding digit is increased by 1. So let me take this one example. If here I have taken this number 22.56 and we have to round off to 2 significant figures. So here the initial significant figure for this number is 1, 2, 3, 4. We have to write this number till 2 significant figures, so means 22. Now the dropped out number here is 5. So, and this 5 is followed by 6, which is a non-zero digit. So it means now we have to increase the preceding digit by 1. Here the preceding digit is 2, so we'll increase this by 1. So my answer will be 23. Now we have here 2 significant figures. Now let's take one more example, 486.59. So here this we have to round off this to 3 significant figures. Here the initial significant figures are 5. Now we have to round off to 3 significant figures, so means 486 we have to write. So here we have to drop this number 5. So this 5 is followed by a non-zero digit, so it means we will increase this digit by 1. So my number will be 487. So here we have 3 significant figures for this number. Next we have rule number 4. If the digits to be dropped is 5 followed by 0, then the preceding digit is increased by 1. So there is a condition, remember, if it is odd number, okay, is increased by 1 if this preceding number is odd, and the preceding digit will not change if it is even. To explain this rule number 4, I have taken 2 examples, 23.50, this number. So we have to round off this number to 2 significant figures. 2 significant initial, how many significant figures for this number? We have 4 significant figures here. So we have to round off to 2 significant figures, means 23. So here also we have to drop this number 5. Okay, 5 has to be dropped, and this 5 is followed by 0, and it means, so here we have to see whether the preceding number is even or odd. If this number is odd, then we have to increase this number by 1. If even, then no need to change. So the preceding number is 3, which is odd. It means we have to increase this number by 1. So after rounding off, we'll get the number 24. So this number has how many significant figures? 2 significant figures. So let me take one more example, 34.50, round off to 2 significant figures. Here also we have to round off till 34. So dropped out figure is, digit is 5, and the 5 is followed by 0. So what we have to see? We have to see that whether the previous number is even or odd. Now see, this number is even. So if number is even, then there will be no change in it. So it means this number will be after rounding off, we'll get this number as 34, which has 2 significant figures. I think this is clear, rule number 4. And next rule is 5. Rule number 5, if the digit to be dropped is 5 followed by nothing, we don't have anything, then the preceding digit will be unchanged if it is even, and the preceding digit will be increased by 1 if it is odd. Let me take one example here. So first example here is 23.5, the round off to 2 significant digit. So initial significant figures for these numbers are equal to 3. So now we have to round off till 23. So next digit is 5, which is equal to 5, and after 5 we don't have anything, means nothing is there followed by nothing. Then now we have to see the previous number. This number is odd. If this number is odd, then we will add 1 to 8 when we have to round off this number. So we will get after rounding off this number we will get 24, because we have to add 1 here. So now the significant figures for this number equals to 2. Let me take one more example here. 23.95, round off to 3 significant figures here. So here we have the initial significant figures are 4. Now see, we have to round off to 3 significant figures, means 23.9. So we have to drop here 5. 5 is not followed by any number, so what we have to, and the previous number is 9, which is odd, so here we have to add 1. So if we add 1, we'll get 23.10. Is this the correct way of writing this number? No. So what will happen here? So this 1 will go, and we have to add this 1 here. So we can write this number as 24. Is this correct way of writing? No, because this number has only 2 significant figures. So what we have to do, we have to put 1 decimal here and 0. Now this is the right answer for this number. Now this number has how many significant figures? 3 significant figures. Okay. Next example is 24.5. We have to round this number to 2 significant figures. So initial significant figures for this number are 3. Now what we have to do, this is 5, we have to drop here. So this number, we don't have any other number, so it means, and if we see the previous number, this number is even, so it means we are not going to add anything in this. So after rounding off, we'll get our answer equal to 24. And this number has how many significant figures? 2. So last question here I'm going to do is this 234.5. So round off to 3 significant figures. So means the initial significant figures are 4. We have to round off this to 3 significant figures, means 234. So we have to drop here 5. And after 5 we don't have any number. Now we will see the previous number. The previous number is 4, which is even, so we won't add anything to it. So after rounding off, this number will get 234. This number has how many significant figures? 3 significant figures. Third topic in this video, we are going to discuss about the significant figures in multiplication and division. So I'll recommend master all the significant figures rule and rounding off rule before coming to this third part of this video. This is very important to note that in multiplication and the division, the final result should retain as many significant figures as are there in the original number with least significant figure. Explain this with an example. So multiply these two numbers, 321.65 and 21.5. First see the significant figures for this number. So for this number the significant figures are 5, and for this number the significant figures are equal to. If we see, now we have to multiply these two numbers. If we see the significant figures for this number is equal to 5, and for this number it is equal to 3. So least significant number is 21.5. So in final result we'll keep how many significant figures? 3 significant figures. Now we'll multiply these to 321.65 multiply with 21.5, we'll get 6915.75. so how many significant figures are there for this number? 1 2 3 4 5 6 7 significant figures we have. So we have to round off this number to 3 significant figures. So it means we have to write this number in term of 691 till this. So if we see, this number is 5 and this 5 is followed by a non-zero number. So we know if 5 is followed by a non-zero number, then what we will do with the preceding number? We'll increase this number by 1. So here instead of 1 we'll write 2. Is this the correct way of writing? So this number is very big, but we are getting very small number. So to make this number comparable with this number, what we will do? We'll put 0 here. So this is my answer here. Or we can write this number in term of scientific notation like 6.9 into 10 raised to power 3. Now we have to divide these two numbers. The divide significant figures for the numerator is equal to 2, and for this number the significant figures are 3. Now first we'll write here 2.5 into 10 raised to power 5 divided by 4.75 into 10 raised to power 3. So now let me divide these numbers. So we'll get here if we take this, so this will become 10 raised to power 5 minus 3. So 2.5 divided by 4.75, which is equal to 0.526361 into 100. So this will become equal to 52.6316. Now the least significant number is 2.5 into 10 raised to power 5. So it means this number also we have to round off to 2 significant figures. So after rounding off means we have to write these two digits only, 5 and 2. So this number we have to drop here 6. So 6 is greater than 5. It is greater than 5. So it means we will increase the preceding number by 1. So after rounding off this number, we'll get 53. So this is my answer. Next is the significant figures in addition and subtraction. It's little different from the multiplication and division. In addition and subtraction, the final result should retain as many decimal places as are there in the number with least decimal place. Here we have to see the number with least decimal place. So there are two numbers, we have to add these two numbers. So first we'll add these two numbers. So we'll get 37.5, 2, 3, 4 and 4. So now here what we have to, so we have to see the numbers which we are adding with least decimal place. So here this number 428.5 have least decimal place. So we'll keep the significant figure for this number. So we'll keep only one decimal place in our result. So we have to drop this 3, and this 3 is less than 5. So it means my answer will be 445.7. I think this is correct. Now if we subtract these two numbers, we'll get 411.27. Similarly here for this number we have only one decimal place for this number. So for this also we'll keep till 2 only. So we'll round off this number till 2. So this is 7. So 7 is greater than 5. So we'll increase this number. So this will become 411.3. So this is my answer here. So for addition and subtraction, the rule is in terms of decimal places. So this is all for this video. Thank you for watching it.